We're not talking x equals 0 or x equals 2. We're talking 0 equals 2? I don't think so. That's a false statement. So what do you think is our conclusion if I get a universally false statement?
No solution.
No solution. There is no solution, ladies and gentlemen. That means it doesn't matter what you put in that original statement for x, you're never going to get a true statement. Never, never, never. There is no x you can put in that original statement and get a true statement out. Never happens. All right, those are your three types of equations you're going to solve. The most common is this guy. You're going to get an answer, x equals 15. The second kind is when I get a universally true statement. We call that an identity. And we understand that it means any real number will work for x. So my solution is all real numbers. The third type of equation we're going to solve, we're going to get a universally false statement. 7 equals 5, 2 equals 0, 1 equals negative 3, something like that. Notice again, no x is involved. And our conclusion for the universally false statement is no solution. All right, everybody got that down? That's what can happen when I solve an equation. So get used to those three possibilities. All right, let's introduce the concept of fractions. Let's see what happens when I involve fractions in equations.
So that's not.
Let's start with 58 on page 93. This is one type of a fractional expression that you'll see in an equation. Notice, and you might want to put a note about this, a fraction equals a fraction. It's just one fraction equals one fraction. Did you notice that? Simple fraction equals simple fraction. Hey, what can I always do if I have a simple fraction equals a simple fraction? What? I said what? Cross multiply. Hey, ladies and gentlemen, if I cross multiply, no more fractions. Y'all know that, right? If you have a fraction equal a fraction, you can say that product equals that product. So 2 times 10x plus 3, and it's 2 parts, so I've got to put in parentheses, equals 1 times 5x plus 6. I didn't have to put the 1 there, but I wanted to show you I'm cross multiplying. Notice no more fractions. And you have to admit, ladies and gentlemen, it's a good day when there's no more fractions. So we'll just distribute it here. We're going to get x's on one side and numbers on the other. We're going to move parts and change their sign. So I move this term over here, change it to a negative 5, 6. Same with this guy. I get 20x minus 5x equals 6 minus 6. I get 15x equals 0. Should I choose to divide by 15 on both sides, I learned that x is 0. Now please notice that is not a no solution statement. That's a conditional statement. X is a number. The number is 0. Is that okay? Fraction equal a fraction. Cross multiply. Good approach for a fraction equals a fraction. Let's try another one here. Let's try number 49 on page 93. All you texters, put your stuff up. Thank you very much. Hey, notice this is not a fraction equal a fraction. Did y'all notice that? No way to cross multiply. So let me give you a universal strat. Hey, there's different ways to do this. And if you enjoy another way other than the way I give you, go for it. Enjoy it. Prosper. All right. Let me just show you a way that I think is universally satisfying whenever I have fractions involved in an equation. Step 1. Find a common denominator. Step 1 is to find the least common denominator. Can you look at those denominators and tell what the common denominator is going to be?
24.
24. Okay. Just comes about in this case just by multiplying the two together. So I got a common denominator, right? And let me just point something out. If you have difficulty finding the least common denominator, you can always find a common denominator by multiplying the denominators together. Might not be the smallest one. You might have to reduce at the end, but you can handle that, right? You can always get a common denominator by multiplying the denominators together. All right, that's step number 1. That's pretty easy. Step number 2 ought to sound real familiar to you, ladies and gentlemen, based on something that we've done before. What do you think we're going to do with the common denominator?
Multiply top and bottom.
Multiply every single term by the common denominator. Now notice, I got 2 fractions to multiply by the common denominator, but I also got this 4 over here I got to multiply by the common denominator. I got to multiply every term, fraction or no, by the common denominator. So multiply every term by the common denominator. Now I know we've talked about this before, but let me say it again. When I multiply 24 by that first fraction, which part of the fraction do I multiply the 24 by?
Top and bottom.
The top. Very good. Glad you remembered that, because that's kind of important. So I'm going to multiply every fraction by the top. And the whole number I'm just going to multiply by 24. You know, why are we trying to get rid of the fractions, ladies and gentlemen? Hang on just a second. We don't like fractions. Now, I could lose my job if I said that out loud. Y'all won't share it any further than this, right? But we don't like fractions, okay? I mean, they're important, but so is the dentist, but that doesn't mean we have to like it, all right? We want to get rid of fractions because we find it much easier in a life without them. Notice my denominator is disappearing. 3 times 3x, that's easy. 8 times 4x. And 4 times 24 is? 96. Okay, so far? Let's see, that's negative what? 23x. Divide both sides by negative 23.